All right, I'll get started. I wanted to talk to everyone a little bit about my experience and journey of discovery using ElasticSearch for logging. Is anyone in the audience currently using any ElasticSearch-based logging infrastructure? So you all have probably gone down a very similar journey as this, and you may recognize some of these experiences. I've been dealing with basically hating computers since I got involved with computers, so I've been doing a lot of automation. I often get mocked a lot by my colleagues because anytime I'm asked to do something, I'll tend to write a script first before I do it manually. When I need to work in the configuration management, or any configuration space, I tend to work first in the configuration management tool to get my changes to the servers. It's just because I like to be able to be hit by a bus at any point and someone else to take over. I currently work for Booking.com, and I need to establish a little bit of context because I was going through these slides and they might sound a little bit negative, but that's because I work for a very pragmatic Dutch company, and negative is actually kind of positive. We actually implemented agile development at Booking.com as a way to add structure to the chaos that was our development environment. We always test everything in production. Failure is not only expected or tolerated, but it's actually encouraged. We actually have a quarterly budget for the IT people to take the site down. We have a calculated revenue, lost revenue system so that we can actually take the site down. We try not to, but we see that as taking risks, and sometimes those risks, well, most of the time those risks don't pay off and you take the site down. We can do this because we have amazing business-based monitoring. It's really striking to me that one of my first day actually at Booking.com, we had a denial of service attack, a distributed denial of service attack. And before the Nagios monitoring went off, a business analyst walked over to the sysadmins and said, at this point in the day, we should be seeing about a 3.5% uptick in conversion, in commission. We're only seeing, we're seeing a slight decrease of about 0.15%. I think something's wrong with the site. And before he could get that sentence out, our monitoring started to go nuts. But it was the analyst who walked over first. And this is kind of what I think Dylan was talking about using your power users and giving them access to data. We focused a lot of our monitoring primarily on our power users, on the finance, on things like HR even. We have systems for monitoring key performance indicators in HR throughout the company. And this permeates the entire culture. So this environment is fun because we get to fail a lot, and we see that as a learning experience. And so when I talk about failure, I'm not angry about it. I'm actually thrilled about it. And when I say Elasticsearch has been successful for us in our front end, I mean it has failed catastrophically in the front end. But at the same time, we learned a lot about the way that it worked, and we've been able to leverage it much more efficiently than a lot of places. We've started to do some technical blogging to get some of the data about how we do business out into the wild, because I saw that 6 months after we had a catastrophic failure with Elasticsearch, the GitHub guys posted about their catastrophic failure with Elasticsearch, and it was identical to what we experienced 6 months earlier. And I felt kind of guilty that we didn't publish something to say, hey, this is what happened, and here's how to fix it. So this is some retribution for that. So this talk is about getting logging data into Elasticsearch. I first looked at this 18 months ago. The landscape has changed a little bit, but it's very similar. Right now, there's quite a few things to do this. FluentD is Node.js-based, Flume is Java-based, Logstash and Graylog2 are both Ruby or JRuby. When I was evaluating these projects to get logging data into my Elasticsearch cluster, really the two that stuck out the most were Logstash and Graylog2. Logstash is great. It has a large number of input and output filters, or input and outputs and filters. This is because they have a thriving community, and so they have a lot of really cool plugins and can do a lot of really interesting things with it. One of the most interesting features about Logstash was the way they decided to lay their indexes out on a day-by-day basis. So how many people are using Logstash? as a way to get logging data in. So a lot of people, so you're familiar with logging data goes in on a time-stamped index. As far as front end goes, not so much. Graylog 2, on the other hand, same type of system, very pluggable, lots of input-output filters, and ways of manipulating your data and adding more context to your logs. An excellent front end right out of the box. But what Graylog 2 was doing when I was evaluating it was storing all of the logging data in a single index. And that meant that I couldn't take advantage of adding more infrastructure to my cluster. If I added more servers, it didn't matter because I couldn't allocate those primary shards out to the new servers. They've now moved to a system that has uses either a cap on the number of documents or on the size of the index. A lot of my learning process was looking at the difference between using a daily schema versus a capacity-based schema. And some of the things that I like about using a daily schema over a capacity-based schema have to do with the way that I get requests to look at data. I don't generally get requests to say, can you please tell me what has happened over the past 40 million requests to the site. I do tend to get requests like, we noticed some weird behavior that started on October 23rd, and we know that it continued through October 27th. Could you please find out what happened? Logstash's daily index makes it very easy for me to select the right number of indexes to get my queries back very fast. It also makes maintenance operations very simple. Underlying Elasticsearch is Lucene, and to store data quickly, Elasticsearch will do what's called segment its shards into separate Lucene segments. What you can do to increase the speed of your searches is you can run an optimize command, which then condenses all of those down to the number of segments you specify. Or in the case of logging data, you should set that to 1. That means you have 1 segment for each shard. You can do that very easily so long as you're not writing new data to the index. Once you start writing new data, you get new segments in the index. So I can run an optimized query for yesterday's data at midnight plus 10 minutes. I can also then clean up, open and close, and delete indexes. Very easy. I can say I want to keep 180 days worth of data, 90 days worth of data, whatever my requirements are. I can do that, and I can do it very quick and easily. The only downside to this system is that you end up with a large number of shards. Because each index is going to have however many shards you delegate, you can increase the number of shards. You basically have a problem of increasing the number of shards that you need to search to answer a query for an underscore all query, for instance. That can be very detrimental to the performance. So capacity-based schemas, it's difficult to go back and figure out, well, I want October 23rd to the 27th. Which indexes do I need to search for that? Okay, maybe I know that it's roughly 60 gigs of data a day and I can figure out where I need to go back in time, but then weekends are less. There are only 30 gigs of data a day, so how many weekend days? I can't very quickly do that. I have to query the index first to figure out how far back I need to go, or I need to do an expensive query, like an all query, in order to search my data. And maintenance operations are also expensive. Deleting data from a Lucene segment does not actually free that disk space up. It doesn't make your searching that much faster until you run an optimize to flush out the deleted rows in the Lucene segment. So using capacity-based schema, if you want to delete all data older than 90 days, you have to do that through a query delete, which can then slow down it doesn't give you any performance gain, so why are you even doing it? The potential win here is that you can very accurately control the number of shards in your index, and you can lower those down very small so that you don't have to distribute the search out to as many nodes. And then, of course, a shameful self-plug. I've been dealing with Elasticsearch daily indexes for so long that and like I said, I hate doing the same thing twice. I've created a number of scripts for dealing with daily indexes as well as monitoring and interfacing with Elasticsearch as an angry sysadmin and as an angry developer. In my case, I opted to roll my own solution to get data into Elasticsearch. Has anyone else done the same thing? No? There's tons of libraries for interfacing with Elasticsearch. It's a great, thought experiment. I couldn't push Logstash at that point up to 12,000 messages per second, so I needed to do something. And at Booking.com, we have some of the brightest Perl programmers in the world working for us. So the choice between trying to hack on Logstash to get the throughput with no Ruby developers and no prior real in-depth Ruby experience, I opted to implement something in Perl. But this is a monitoring conference, and you want pretty pictures, maybe not those pretty pictures. So here's what intrigued me to go down this road in the first place. I looked at Graylog 2 and I was very impressed. I mean, straight out of the box, I was able to get my logging data, I was able to do searches, and then see graphs that were updated with my search terms. And they have real-time streams in Graylog 2, so I was really impressed with this and I really liked it. You could even do things like graph viz transformations on data in your logging. But again, at the time, all I had was a promise from the author of Graylog 2 that he was moving to a system of multiple indexes, and I was already at a scale in my development environment that I couldn't have a single index for logging data. So then I discovered Kibana, which addressed the main drawback of Logstash, which is the front end was pretty much non-existent. It was there, you could do searches, you could see what was in your index, but that was really it. It didn't provide any operational value. I gave the front end of Logstash to a sysadmin, and he's like, so what? I can search for where I logged into. This is great. Kibana kind of took a different angle, and since Logstash and there's FluentD and Flume and all these other projects could get data into Elasticsearch, Kibana's developer said, how can I make it more interactive for developers and sysadmins to be able to get data out of Elasticsearch? And so it's a very composable system, and it's evolved over time, and now Kibana 3 is completely composable. It's nice because you can actually create dashboards based on particular incidents. For the first time in the history of the company, I had production people able to answer a question about an issue occurring on the website before the developers could get that data from our Hadoop system and figure out exactly what was going on, because they were able to completely compose a dashboard specific to the exact thing that was going on. And it's fast. Elasticsearch is very quick. And Kibana can also melt your cluster. We uncovered some bugs that have been patched in Kibana that would kill a large Logstash cluster. And has anyone not played with Kibana that's working with Elasticsearch? Because this is some of the just real quick screenshots to woo you with the ooh and all factors. You can do pie charts. I don't know why you'd want to, but you can. You can map your data, histograms. You can see top terms. You can customize everything. Completely. It's a very nice interface. You can make it look like your graphs are on fire. And again, more pie charts. At this point of seeing all of these things that we could do with Elasticsearch, I thought this is awesome. This is magic. I don't know how much operational experience people have with the clustering system in Elasticsearch, but you just add a node and it works. You don't do anything. It's kind of scary, and it really is black magic. And this is where I start talking about some of the failures. And like I said, I come from a very pragmatic Dutch company, and we talk about failures because we like them. If this is don't take this bad. This is good. One of the first cool features about Elasticsearch is this feature called auto-expand replicas, which allows you, if you're running like a search-based cluster, like say geolocation-based search, and you have a single index, and it's not that large, maybe it's a few gigs, and you want to increase your search capacity, you can just leave this feature enabled. It's enabled by default. And when you add a new node to the cluster, your index data will be automatically replicated to that node, and that node will begin answering queries in the cluster, so you will actually automatically scale up your search performance by just simply adding a node. And it's literally like as soon as Puppet starts Elasticsearch, you start getting data onto this node, and it almost, as soon as it's done copying data, it begins answering queries. So there's no interaction that's necessary. The reason that this is potentially frightening and really bad for a logging cluster is that means if I'm trying to add capacity and I throw in a new node, all of the indexes that have this set will then attempt to copy themselves to my new node. So this can cause a little bit of issue on your backplane of your switches, especially if you have multiple nodes coming up at once and they're replicating data from all over the place. We've had this, this hit us pretty hard when somebody sent a bad query to our front-end search cluster, which knocked a node out of the cluster. And then when it came back up, the cluster was fine until the second node, or the node that failed, came back in. And all of a sudden, the way that the sharding, the cluster order of operations works, it dropped all of its data first because auto-expand, this is one of the features of auto-expand replicas, is that when the node is joining the cluster, it says, hey, I'm here and I'm looking at the status of this index, and the cluster goes, well, since you're not authority, you haven't joined this index yet, I have n+1 copies already, so I don't need your data. So the node that's joining the cluster then says, oh, okay, so it RMs everything off the file system for that index. And then it completes its join into the cluster, and then the cluster goes, oh crap, I'm now at n-2 replicas. Here, take all of your data back. And you start replicating all of this data again, even though it was on disk already. So this is where understanding shard allocation is interesting. I've worked with Shai from ElasticSearch a lot on how shard allocation works and better ways to optimize it, and they've spent a lot of time working on this. This is kind of how I run the production logging system. It's not exactly, it's a simplified version, but we have as an index, and I kind of mock the head plugin display of the index where I have 3 shards, I have 3 nodes. The green ones are primary, so these are the nodes that will receive writes for these shards. And I have the number of replicas set to 1. So I can lose a single node in this cluster and still be able to answer queries and still be able to index data. I can't lose 2 nodes because then I'll lose a single shard from the index, and the index will no longer be writable and will not return any search results. So what happens when node 3 leaves? The cluster says, okay, I don't have 1 replica of every shard now. But I promoted my number 2 shard on node 2 to primary so I can start taking writes. So everything's good. Now I am copying the data from shard 2 from node 2 to node 1, and for shard 0 to node 1. So if these shards are 20 gigs each, I'm now copying 40 gigs of data bilaterally. Eventually, everything's happy. Our cluster is back into a green status from a yellow status. We have no shards initializing. Everything's carrying on. I fix node 3, and I bring it back into the cluster. So what happens now? Like I said, with the way that the shard allocation algorithms work and the way that the clustering mechanisms work in Elasticsearch, this is very difficult. So node 3 comes back into the cluster and says, hey, I'm here. And the cluster says, that's awesome, I'm already good on that index. Why don't you go ahead and delete your data? So node 3 go ahead, drops this data. And then it realizes, wait a second, I'm out of balance. I have more data on these nodes than on these nodes than on this node down here. I need to move that data from the 2 nodes that had all that data down to the node that just joined the cluster. So even though that node, and this may have been yesterday's index, right? So there's no writes happening to it, so it's going to be identical to the data it deleted. I'm going to recopy all of that data back. So this can be slightly problematic, and there's an edge case which I have a bug in now about, which is what happens when this happens, when node 3 goes, or node 2 goes away in the middle of this initialization. If the master changes as a result of this, it loses track of where shard 2 was actually the primary, and it fails back to timestamps. So then when node 2 joins back in, even though it has a good shard 2 that's complete, and node 3's shard 2 is incomplete and corrupted at this point, it will drop node 2's shard 2, and now your index is completely unwritable and not searchable. And unless you have a backup of that charge, you're not going to be able to get that data back. Shai is working on a patch to fix this, but how do we prevent it? Well, if we're doing maintenance, if we're doing planned maintenance, the easiest way to work around this problem is to completely disable the reallocation of shards. This will not prevent you from indexing data, this will not prevent you from searching data, but it will prevent the cluster from attempting to move shards around the cluster if the cluster state changes. It's not a happy situation, but for maintenance and stuff, this is really insanely helpful. And then when you're ready to go again, you can re-enable the allocation, and the node that has started up will already know what it has, and it will have checks on that data, and it will not copy that data across the network. So that was one interesting lesson. The next thing was learning about the way that Java does memory management. This was new to me. Out-of-memory errors in Perl just take the box down, and I'm cool with that. Some weird things start happening in Java. Java says you can set your maximum allocation for memory, and then weird stuff happens, and if you don't know all the voodoo of the JVM, which I've slowly learned, and much rage learned how this works, you end up with interesting problems. One of the problems with a distributed system like ElasticSearch for queries is that it's very difficult to implement an effective query killer. So a bad query will run, and it will run until it feels that it is complete. In some cases, if you get into bad situations with memory and you end up in a GC loop, you won't be able, your timer for timeout will actually not fire. So your query may run for, I had one run for 90 minutes before I killed the ElasticSearch index, the ElasticSearch process entirely. The memory is limited, and ElasticSearch aggressively caches data. And that caching occurs in the same memory space as the rest of the operations, the regular search operations and the regular indexing operations. And normally this is an amazing thing, except for when it's not. Another issue, which is almost completely alleviated in recent releases, is the thread pools are malleable by default. The amount of pools that it has for each function were flexible, and it would just keep going until the system died, basically. But Shai's actually patched that in 09.0, so it's not as much of an issue as it was before. But I started seeing graphs that looked like this very early on, and got very concerned. What you see here, the vertical lines represent times when the old generation garbage collection in Java had stopped all threads for more than a second. And some of these, you can see it was going for quite some time, and the red here is the heap memory usage. So if all threads are stopped, you're not indexing data, and you're also not searching data, which is bad. So I found some ways to prevent some of these problems from occurring, and we've had some actual really nice stability for the past few months now. You can configure how Elasticsearch allocates memory for caching. So you can use these parameters to set expiries for your cache data, which the default is never expire, which doesn't make sense for a daily index type situation, but does make sense for a more static index that isn't changing as frequently. And also the field data cache. And field data cache is used for things like facets. Is anyone not familiar with faceting in Elasticsearch? It's basically the SQL group by, so you can do analysis of the top source IP. For instance, if you have a field called source IP, you can actually do statistical facets on data. So if you have integers, you can get the mean, median, standard deviation, all of that stuff by element type. So it's basically like an aggregation function similar to SQL. So that cache is also not limited by default. So what can happen is if somebody does a terrible, terrible facet, like they facet on the refer, for instance, with parameters in the URL, and so there's actually, there's very little commonality, then what you end up with is you consume all of this memory to store the cache of that facet. And that can impede the progress of your indexing and back you up into old generation garbage collection. So by setting some of these parameters, and you have to play with them based on the memory size and your use cases, you can tweak these to make the search still responsive and not have it kill your cluster. I mentioned thread pool management. It's not really as relevant anymore, but if you're working with a logging cluster, you may want to actually look at the indexing and bulk thread pools and set those and make sure they're allocated well, because you're going to be spending most of your time indexing. So the ElasticSearch.yaml file provides an API for being able to do this, and it is a configuration change that requires a restart. I do network security. I've done network security for a while. And we ran into some issues when we were talking to our PCI auditors about access control for audit data. So I asked Shai, how do we audit this? How do we control this? Unfortunately, there are no solutions. If you can search an index, if you can search an index in Elasticsearch, you can search all indexes in that cluster. And if you can search an index in that cluster, you can also modify data or delete data from that cluster. You can delete an entire index from the production cluster with a click and typing the word delete in the head plugin. So there's not a concept of ACLs and restrictions. And I've gotten asked a question about this in the past, talking about Elasticsearch. I don't consider it a system of record. It's not there for legal uses. It's not going to satisfy your PCI or FSMA or FERPA requirements for audit log retention, because anyone that can search the data can modify or delete the data. But that's okay. Dealing with just that problem is really cheap and really easy. And there's something interesting that happens once you start using Elasticsearch for your data. You no longer have sysadmins logging into boxes, doing zgrep over massive amounts of log files. They don't want to touch access logs. They hate access logs. The stuff you have to do to get useful information out of access logs sucks. If you have that data in Elasticsearch, they don't want access to your log retention servers. So just keep a server that just spools syslog data to tape or to disk and compresses it off, and no one's ever going to want to use it again. But like I said, I really like Elasticsearch. I love Elasticsearch for this case. It's a technology that is constantly amazing me with what you can do with it, and what other people that you didn't think would even think it's cool can do with it. And there's a few reasons for that. Kibana is a main driver for me because it allows people like business people to start looking at system log data, which then they, like, I think it was Theo was talking about other people, getting other people outside of our groups to look at data. This is exactly what this enables. You can hand this off to a business analyst and they can actually extract data out of your system logs, which is amazing and unexpected. Again, because there's no ACLs, everyone has access to it and everyone can play with it, which is great. We trust our employees. We hired them. We're paying them a salary. If we didn't trust them, why are they there? We shouldn't limit their access to data unnecessarily. There's some caveats, like if you're working in the banking industry or consulting business and you don't want clients to have access to other clients' data, that makes a lot of sense. But if you're just trying to provide some operational value to your organization, don't restrict who has access to that data. It also features a very simple API. It's REST-based. You can interface with it from the command line. You can get data back in JSON, which again, there's command line utilities for viewing and extracting data from. It's just easy to work with at every layer. And it has pretty pictures. You can get pretty pictures from Kibana and from Graylog2 and from a lot of other open source stuff. And the most important thing is those pretty pictures and those interfaces encourage people to interact with the data. And when they're interacting with the data, they do things that you don't expect. And I had one guy come up to me and tell me that he was able to use the access logs to determine that the IP address of an attacker who was trying to crack someone's account, because he had the email of that person, and he was able to look very quickly at which IPs had accessed the reset password using that email address. And I was like, okay, now I have developers answering security questions for me, which means my small team of security guys can focus on the hard problems by giving the tools that matter to the people that can play with that data. And that's why I pitched this Elasticsearch for logging. It's like Graphite. You know, when you first sit someone down at the Graphite Composer, they're like, what is this? I don't see any dashboards and it's not pretty. But the second they get it and they can start correlating data together, and they're not restricted by someone's interpretation of what that data should look like, they do things that you don't expect, and they add more value than a simple dashboard ever could. So if any of this sounds exciting, Booking.com is hiring. We deal with problems at scale. We A/B test stuff. We break a lot of things constantly, and we reward the people who break it. So come see me or hop on the site. That's all I have, unless you guys have any questions.